Let me welcome you to the Analytic Green Engineering Methods, Sustainable Green Engineering, and Process Modeling Part 2, which is dealing with the Sustainable Green Engineering modeling methods, the notations, and the examples that will help us to understand the notations. This is an IEEE e-learning course by Paul G. Ranke. Paul G. Ranke is a full-tenured professor of engineering design, manufacturing, industrial and management systems at the Department of Mechanical and Industrial Engineering at NJIT, New Jersey, USA, with an additional faculty appointment with NJIT's IT as Professor of IS and IT. He is also the IEEE Green Engineering Editor. Now, NJIT is the public research university of New Jersey, Newark, New Jersey, USA. He is a member or former member of SAE, IEE, IET, IEEE, PMI, SME, ASME, ISPE, International Society of Pharmaceutical Engineers, ASQ, the Lean Manufacturing and the Quality Auditing Division. He is also a registered and chartered professional engineer specializing in integrated product and process design, sustainable green engineering PLM, using digital product, process, manufacturing, and factory design methods and tools, concurrent simultaneous engineering, InDesign for manufacturing, assembly, disassembly quality in quality system design and auditing, advanced lean and flexible cellular manufacturing systems and industrial engineering, in assembly automation and robotics, in high-tech project management, in requirements analysis, in process risk analysis, in total quality management, in designing and operating lean systems, in designing electronic user and maintenance manuals with 3D web content, and in underwater exploration and device test engineering as a PADI certified rescue diver with USA and internationally recognized academic, industrial, and engineering management experiences. So, just a few words about green engineering process modeling. Process mapping, process modeling, and dynamic simulation methods enable engineering management to understand the static and the dynamic interaction of systems and their components. And this is why we would like to understand green engineering systems, and by modeling them, we have a good chance to do so. In other words, these methods enable management to see the future, in a way, learn from the past by means of analyzing basic data sets using statistical methods, and by means of data mining processes using IT methods. So the goal of this section of the program is to offer an introduction overview of sustainable green engineering related systems and process modeling methods, explain the reasons why we have to follow process modeling methods and standards, and illustrate the importance of this subject area with real-world and research examples and challenges too. So what is a green engineering system, and how can we actually show this in a process model or a system model? Well, a green sustainable system is a complex grouping involving man, machines, and material, and data and information, and also financial resources that satisfy our already defined green criteria. Now, green engineering systems can be broken into subsystems, and individual subsystems can interact with each other, as well as within themselves, at defined interfaces by input-output matching. A system forms part of a hierarchy of systems with definable interfaces, and a system must have an overall objective. The objective for us is to create sustainable green systems. Maximum effectiveness of a system is only possible after effective design. So obviously you have to capture this whole sustainability opportunity at a very early stage, so do it at the design stage versus later on. This is clearly visible when designing sustainable systems. Now, due to complexity, every object or component in such a system must have a sustainable green engineering built into its design to be effective. If a system has significant human involvement, amongst others, it must consider cultural, social, and behavioral aspects and constraints too, because in one country or one continent, something that is considered to be sustainable and green isn't going to be sustained in another. And also time is a very important issue, something that we dealt with 20, 30, even 50 years ago and considered to be a good solution is not a good solution today. As a very good example, just look at mercury and silver fillings. About 30, 40 years ago, this was a widely accepted metal for dentists. And today, of course, we all know that this is a very toxic metal, and we shouldn't do that. So there are some very important cultural, social, and behavioral aspects that are sometimes supported by science, just like in the case of mercury, but sometimes are not supported by science, but they're just cultural, social, behavioral issues, the way they're moving on. And I will show you several examples of that. For example, recycling and the way we deal with waste is a very good example, and the way that it's culturally embedded now into our society to take care of recycling, for example.
Thank you for watching this course sample from the IEEE eLearning Library, the premier online collection of short courses and conference workshops. Please visit www.ieee-elearning.org to purchase the full version of this and other courses.